So this is a combined lecture, and in one section probably just I mentioned about this production. So today I am going to discuss about production initially. I believe you can see and as well as you can hear me clearly.
Yes, sir.
Okay. So initially I will start with production, then I will move on to cost, but it will take some time. So let's move in that way. Now, when we talk about production, you are also having some idea about production. So what do you mean by production? If anyone like to answer quickly. So what I said might be in one section, that production is a process by which, initially I said that production is a process by which inputs are converted into outputs. Now, but at the same time I said that this is not a complete, say, explanation of production or complete discussion of production, because classical definition of production, you will get it in microeconomics book, but even otherwise also, I give that example of, suppose you are interested to produce a pen, you are having a pen manufacturing industry. So while producing this pen, you might be using, you are using, say, your, might be you are using plastic, piece of plastic. Before producing that pen, you are gathering piece of plastic, ink, then your little bit of steel also might be. But along with that, in your production, you might be using other kind of inputs also, like machine, like labor, like electricity, like building. So there may be n number of inputs. So is the case, say someone say that I am producing rice in a field. So in production of rice, you are using land, you are using labor. That labor may be human labor, animal labor, machine labor might be, because you might be using power tiller or tractor for preparation of land. Similarly, you are using seed, you are using irrigation, fertilizer, pesticide, or other kind of chemical. So in that way, there may be n number of inputs you are using it in your production. So what I said, this is a process by which inputs are converted into outputs. But why I said still it is not complete? Because think about your production of pen. The moment if you go and approach a person that, okay, I am here to produce pen, but I am having this piece of plastic, so I am offering you, you give me 1 rupee. So the person will simply refuse it, because that piece of plastic doesn't have any meaning to him. But the moment you converted it into a pen along with other inputs, he or she might be interested to purchase it at 5 rupees. So what I say, that in the process of production, what happens, you are adding value to that goods or commodities. It become much more useful. Because of that, people are looking for it. Because of that, what I say, that production is a process by which inputs are converted into output with value addition. You are adding value. Okay, you are adding value, and accordingly, you are just going for production. But that value addition may be in different forms. Because sometimes even value addition may be in different way, you can think about. But anyway, as I said, that this is not a classical definition, but as much as possible, you try to make it complete. Now here, 2 different terminology I use it. Another is input, one is input, another is output. So what is input and output? The input and output means anything that goes into the process of production is called input. Anything that goes into the process of production is called input. In economics, We usually consider like land, labor, capital, entrepreneurship, because what happen, your entrepreneurial skill, organization, that is also you are using it, because some of your inputs may have physical presence, some of your inputs may not have physical presence, like labor. Labor directly you are not using in your production, you are using actually labor services. So in that way, and output means anything that comes out from the process of production is called output. Like in the process of production of pain is the ultimate outcome, or you are producing rice is your ultimate outcome, output. Okay, clear? Now here you are getting two different kind of production process, maybe depending upon the duration, like short run and long run. Another concept is coming, that is short run and long run. Short run refer to a time period where certain inputs remain fixed, certain inputs remain variable. So another terminology is coming, that is your fixed input and variable input. Fixed input, and another is variable input. Fixed input and variable input. Okay. So what do you mean by say short run? What I said, short run refer to a time period where certain inputs are fixed, certain inputs are variable in nature. Means that may happen when you are considering a very short time period. Short time period means maybe 1 day, 1 week, 1 month, depending upon what kind of product you are producing. But otherwise, in that process of production, certain inputs are fixed, certain inputs are variable. Let me give you an example. Okay. Say for example, suppose you are producing, say, a particular product, then suppose you are having a factory, you are producing a particular product, say for example pen, what I said already. Suppose you are producing a pen. Suppose you are considering a time period of say 1 day. 1 day. Today you are considering that production. In this 1 day, if you analyze your inputs carefully, what you will observe, if you analyze your inputs, say think about my example. Say in that process of production of pen, someone may produce 1 million unit of pen, someone may produce only 1 unit of pen. So accordingly, say suppose it may be 1 day, it may be 1 week. Suppose production time is you are considering 1 week, suppose. So in this time period, you may produce maybe 1 million also, you may produce even 1 unit of pen also. So accordingly, requirement of your plastic, if you produce 1 million unit, okay, this is 1 million unit, requirement of plastic will be vary. But if you produce only 1 unit of pen, then your requirement of plastic will be different. If you produce 1 million unit of pen, might be requirement of your labor services will be different in comparison to producing only 1 unit. So depending upon the level of output means Q, depending upon the level of output Q, some of your inputs requirement will vary, like plastic, like your labor services, like your So when you require more, when you are producing more, you need more labor services. So you might be hiring, might be labor from labor market, casual labor. Okay, you might be hiring. So I need 100 more labor for producing 1 million unit of pen. So you might be hiring from labor market. These are daily wage labor, casual labor. Okay, but requirement of pen, requirement of plastic, requirement of ink, requirement of steel, all these depending upon the level of output, this may vary. Or might be you are running that machine, your factory for 20 hours because demand is very high, or you need to supply more. So because of that, you are running your machines and other things 20 hours maybe. So your consumption of electricity will be more. So accordingly, your requirement of electricity for running of your or lighting of your room or this one. So that requirement will be more. So depending upon the level of output, these inputs may vary. Some of your inputs are vary. These are called variable input. Depending upon the variable inputs are those inputs whose quantity varies depending upon the level of output. In short run, I'm discussing about short run. But think about some other kind of input in short run itself. Like you are considering 1 week time period. 1 week time period is short, suppose. It may be 1 day also. It may be. Or it may be fortnight also maybe. Or it may be 1 month also maybe. Some of your inputs like building. Think about the building where you are producing. Number of building cannot change within a month. You need longer time period, maybe 5 years, 10 years to purchase land, to construct a building and so and so. So number of building cannot change over in a day or in a week. Number of permanent labor cannot change in a day or in a week. Number of machine cannot change in a day or in a week. So these are that example of fixed input. Irrespective of level of output, these inputs, fixed inputs remain fixed. Irrespective of level of output, fixed inputs remain fixed. Okay? Irrespective of level of output Q, whatever may be the value of Q, but fixed input remain fixed, like number of building, like number of machine, like your permanent staff, because these are the permanent staff. The meaning itself says that to recruit a permanent staff, you need time. You need to go for advertisement, you need to take interview, you need to recruit. After that recruitment, you need to go for even their training also, basic training before involving them in different factory work and so, different way. Okay, so in that way, your these fixed inputs remain fixed in short run. So in short run, when time period is long, time period is very, very short, some of your inputs are fixed in nature, some of your inputs are variable in nature. But in long run, suppose you are considering a time period of, suppose in long run, you are considering long run, you are considering a time period of say 5 years, 10 years, 20 years. Most of your inputs may be variable in nature. Like number of building in a 5 years, 10 years time period, I may think about raising one more building for my production. Number of permanent staff may change. Number of machine may change. I may purchase even a new machine. But even in long run, in economics, we assume that even your technology is at certain level, even in long run. The meaning is technology in earlier time period, to change a technology, you require sometimes 50 years, 100 years. Because of that, even in long run, we assume that your technology is at certain level, the way you are producing technology. But in very long run only, we assume that even technology may change. For changing a technology, we consider a very long time period. Okay. So in that way, we just consider it. Okay, just give me a minute. Can you hear me as well as can you see the Word file where I am writing?
Yes, sir.
Okay. So in case of event technology, we assume that in long run event, we assume that technology is at certain level. But we consider in very long run only your technology may change. Okay. So these are, so you remember ultimately what I mean to say, that suppose Q is your level of output. So production may be a function of your, say, labor, capital, land. Okay, it may be land or it may be land and building, maybe you can term it in that way also. Okay, it may be other kind of material also, maybe. So in that way, it may be technology also, maybe, and it may be even time also. So in different way, your it may be time also. In that way, it will go on. Say what I said in the production of, suppose Q represents here production of rice. So production, this level of output may be a function of your land, might be your seed, fertilizer, irrigation, pesticide, your labor, it may be human labor, machine labor, animal labor, so and so, time, technology, other kind of technology, so and so. So there may be n number of factors, and please remember, as we usually use softwares, econometric software or statistical software, we usually consider n number of variables in production, and mostly we consider long run. Obviously, we will discuss short run initially, then we will move on to discuss long run situation. That we will do it, but otherwise, in most of these cases, we discuss directly long run situation where many of your parameters may change simultaneously. But for your simple understanding, because we are using a two-dimensional space, because of that, here we are expressing production as a function of capital and labor. This is in long run. This is in long run production function where both capital and labor are variable. In short run, we discuss production is a function of capital and labor, but here we are using a K bar. This is in short run. The meaning is capital is not zero. Capital is at certain level. Means capital is a representative of all the fixed inputs. Short run. And labor is a representative of all the variable inputs. But in case of long run, both capital and labor are variable in nature. But we are using a two-dimensional space, we are mostly considering production function in this way. In long run, capital and labor, short run, K bar and L. K bar means capital is at certain level. Okay, this is one. But please remember, when we use econometric software or statistical software, we use a long n number of variables which are appearing. Now, in production, whether it is short run or long run, it is based upon certain assumptions. Yes, please.
Say long run, labor and capital both are variable inputs.
Yeah. Actually, yeah, long run both actually means there are all and inputs are there. all inputs are there, but the problem here is that we can only use two-dimensional space, because after some time you will find that we are going to use different, we are going to draw different diagrams. Now, as it is two-dimensional space, one diagram will be, one dimension will be, or one axis will be capital for capital, another axis will be for labor, third axis maybe you can consider as Z axis, maybe for quantity, Q, third axis maybe. So in that way, we are just doing it. Okay. But in reality, there it is supposed to be multidimensional. And as we are using different softwares, during that time, we are using n number of variable only, not only two variable, but for simple understanding here or in any economics book, you will find only two variable they are just considering. Okay. Only two variable we will consider here. Now, this production based upon certain assumptions. So some of that assumptions already I discussed indirectly, that here only two factors of production we consider, means labor and capital. Whether it is in short run, we assume that capital is at certain level, labor is variable, but in long run, both are variable. So only two variable we consider, two factors of production or two inputs you can say, consider. Then there is perfect divisibility of both inputs and output. Means using a small quantity of inputs, you can produce a small quantity of output. Okay. Perfect divisibility of both inputs and output means using a small quantity of input, you can produce a small quantity of output. Then another is limited substitution of one factor for the other. Means limited substitution of one input for the other. Limited substitution of one input for the other means capital can substitute labor or labor can substitute capital at a decreasing rate up to certain extent. Means it is imperfect substitution. Technically, in general, I'm talking about. So in general, it is an imperfect substitution. Means capital can substitute labor or labor can substitute capital, but at a decreasing rate up to certain extent. Why? Because think about a production process. Say I am producing pen in a factory. Now, some of that producer may produce pen by using more number of labor and less number of capital. And some of that producer may produce pen by using more machine. Maybe almost fully automatic production process maybe. But even it may be a fully automatic production process, then also you need minimum one labor to switch on the machine. No producer will go to that level. For your information, I am telling you, because you may argue with me that no, I will go for fully automated system. But there must be minimum few number of labor, at least to switch on that machine, to clean that production unit, then to look after that machine. So maybe for maintaining that machine, you need people. If anything goes wrong, then there will be a catastrophe, because no one is there even to look after that machine. So machine was not working fine. What will you do? So if you say that no, 100% labor I will replace by machine, it is almost impossible. No producer go for that. Your number of labor may decrease, and someone might be doing this or producing similar kind of output by using labor. His production process may be more labor intensive. Because of that, I am saying that capital can substitute labor or labor can substitute capital at a decreasing rate up to certain extent. Now, another assumption, that was the third assumption anyway. Then another assumption is your technology is at certain level. Then another is, that is already discussed. Technology, we assume that whether it is a short run or long run, because we assume that in very long run only technology may vary. Maybe 50 years, 100 years, something like that. Then another maybe your, in short run particularly, this assumption is applicable for short run, that in short run, inelastic supply of fixed factor, this K, this one, this will be inelastic supply. Inelastic supply means irrespective of level of output, capital remain fixed in short run. Now, let's move on to discuss short run now, short run production. Short run production. Short run production is also called your production with one variable input, because you remember your here output is a function of output is a, yes.
Why labor is not considered as capital?
Why labor is not
Considered as capital, like why it is not included inside capital? Why these two are different things?
because here labor is a symbolic of or representative of all the variable inputs. Capital is a symbol here to represent here all the fixed inputs. Like your capital means your building, machine, all these, and labors are mostly variable here. Okay.
Okay, sir.
Even I am telling you, do not confuse about this one. Whether the basic purpose is what, the basic purpose of discussing even short run or long run, whatever it is, okay, is here production which, do not confuse about this one, production with one variable input, with one variable input. So the issue here is not whether it is labor is variable or whatever is variable. We are producing something in a short run. It may be raw material. This is symbolic. Say plastic. Few minutes back I was telling you, suppose I am producing today's production activity. So in today's production, what I mean, depending upon the level of output, suppose my raw material, that plastic is variable input. Okay, that is my input, plastic. If I produce more, I need more plastic. If I produce less, I require less plastic. Means, I'm giving you an example. Suppose you have a factory, wherever you are there, suppose right now, wherever you are attending this class maybe, or any factory, suppose there is a house, that is your production unit. Machine is already you arrange it, labor is also arranged, everything is there. Or suppose you want to make labor variable, suppose I am giving you an example, other way, suppose keeping labor only, suppose a factory is there, where everything is arranged, like raw material is already there, machine is already purchased, all other, or except labor, everything is there. Suppose I am considering x-axis is the labor, okay, and y-axis is your Q. Q is nothing but your total product. Q is also called your total product. Okay. In that factory, what is happening? Labor is not there, but otherwise everything is you already arranged. As labor is not there, production is zero. Now you started increasing labor. Initially 1 unit, 2 unit, 3 unit, 4. In that you are going on increasing labor. What will happen to your output? Output will start, because you will start with 1 labor, then 2 labor, 3 labor, in that way. There will be some changes later part. But that is happening. So that we are going to discuss, means production with one variable input. Labor is variable here. Except labor, this doesn't mean that other inputs are zero. No. In your factory, machine, raw material, everything is arranged. Already it is there. But labor, as labor is not there, production is zero. Production is yet to start. situation is like that. And sometimes it may be your other kind of variable also you can consider just like a variable input. The basic issue is here that you are producing something with one variable input. All other inputs are fixed. Except that variable input, all other inputs are at certain level, fixed. This is the meaning. So this short run production is discussed with the help of law of diminishing marginal return. Here comes your another concept that is called your law of diminishing marginal return. Law of diminishing marginal return. Yeah, someone is saying something. Law of diminishing marginal return. Okay. Because in short run, your input-output relation is explained with the help of in different way, like laws of variable proportions, laws of return to a variable input, or law of diminishing marginal return. Okay, but in long run, which we will discuss it later on, you will find that laws of returns to scale you will find in long run. Okay, laws of returns to scale you will get it. But anyway, right now as we are discussing short run, I am going to discuss law of diminishing marginal return. Okay, think about the factory in my example. What I say, when more and more unit of a variable input, what law of diminishing marginal return says? When more and more unit of a variable input, in our case, in our example, it is labor. More and more unit of a variable input is added or applied to a certain quantity of fixed input. In our case, it is capital. This is a symbolic, means all other inputs are at certain level. Yeah, someone is saying something. Is someone saying something?
No, sir.
Okay. So let me explain. After that, anyway, you will get the opportunity to ask. Because I am in other screen where I am writing it here. I am not in your MS Team that screen. It is behind the scene that screen is working. So because of that, I said that if you want to have any question, you can ask me by unmuting your system using your speaker. Do not write anything in your chat box because I will not be able to see it. I will not be able to know actually your question. So law of diminishing marginal return, what it says, when more and more unit of a variable input, in this case labor, is added to a or applied to a certain quantity of fixed input, the output may initially increase at an increasing rate. Then it will increase at a constant rate. More or less, you may get this kind of your relationship. Means what I mean to say, suppose your production function is like this, Q equal to minus L cube, cubic production function I am considering, plus 15L square plus 10L. This is your production function, suppose. By seeing that production function, you should understand that here your output is dependent on labor. Means the moment you are changing your labor, accordingly your level of output is changing. This is an example of your short run. So what is happening here? This kind of equation you can solve it three different ways. This is, I draw this one, this is your total product, but do not worry and do not jump into it. How you can solve it, I am telling you. This is in general, I am drawing it without even drawing that one equation or any kind of equation. In general, the shape will be something like that. Okay. It will be something like that. Anyway, so suppose a production function is given, suppose, okay, in this way, like minus L cube plus 15L square plus 10L. You can solve this one three different ways. One is tabular way, graphically, and numerically. You can solve it quickly. Obviously, you are good in mathematics, so you will obviously go for numerical way, but I am telling you other way also. Suppose, first of all, you do not know anything, so tabular form you can do it. Suppose L is the unit of labor, number of labor. So using this one, what you can do it, just a minute. So you started with 1, 2, 3, 4 in that way. You are going on in that way. Against this labor, you will get the value Q. Q is nothing but your total product. Okay, total product with respect to labor, you can say. This value you are getting it. Say when it is 1, it will be 10 plus 15 minus 1, 24. Total product. When labor is 2, you can find it out. Here it is 8, and here it is 60 plus 20, 80 minus 8, 72. In that way, you can find it out. These values, you will find it out, Q. Then another issue will come into picture, which I need to draw actually here. I'm yet to draw it here. That is your average product. Average product with respect to labor. So average product with respect to labor means what? This is equal to Q by L. Q by L, output divided by labor. Means this column Q divided by L, that will give you on an average what is your per unit of labor is producing. Average product with respect to labor. Means on an average per unit of labor is producing how much. That you are just calculating it out. Like here, say for example, it is 24. This is your 36. This is your, in that way you will go on. Now another is your marginal product. Marginal product with respect to labor. Marginal product with respect to labor is what? It is the first order derivative of Q, dQ divided by dL. Means in your production, if you add additional unit of labor, that additional unit of labor will produce some extra output. That output is represented by, that additional output will be represented by marginal product of labor with respect to that particular unit of labor. Means it is the first derivative of this equation with respect to labor. So in other way, marginal product of labor or average product of labor, let me use a different ink. Marginal product of labor, so MPL, marginal product with respect to labor's equation will be what? Minus 3L square plus 30L plus 10. That will be the equation for marginal product. What will be the equation for average product of labor? Suppose I am writing it here. Average product, this is Q by L. Q by L means APL equal to, this is you are dividing by this, so it will be minus L square plus 15L plus 10. This is the equation for average product with respect to labor. The moment you get this one, then for different level of L, you can easily find it out this value. Say when L value is 1, here it will be, L is 1, it is 40 minus marginal product is 1. So what will be its value? This marginal product value when L is 1.
37.
So 37, it may be 37. Then when L is 2, it may be, you can find it out in that way. L is 2, suppose. So in that way, you can find it out. Anyway, you can find it out those values, maybe. Or I do not, please remember, I didn't check the equation, whether equation is correct or not, I didn't check it. But anyway, if you open up any economics, any economics book, you will find maybe your any cubic equation, you can plot it. And the moment you get those values, then you go for tabular form, then you go for graphical presentation. Then here, if you bring average product and marginal product in same curve, suppose same graph, then you may get another this one, like suppose I'm using a same this one, then you may get something like that. Approximate, these are approximate, but if you plot it in a graph paper, you will get it. Something like that is and another, maybe let me use a, even this diagram is not very good, but anyway, sorry, in general, I'm just trying to show you. In that way. You will find different, in that way, you will find actually different stages of production. This is stage 3, this is stage 2, this is stage 1. So what is happening here actually? Just give me a minute. Just give me a minute. So here, what is happening? When you are keeping capital at certain level, when you are going on increasing this labor, then your output will behave in this way. That is explained by law of diminishing marginal return. What it says, and from your marginal product curve also you will get some idea. When you are increasing your, when a particular or fixed variable, sorry, when a variable input is added to a certain amount of fixed input, your output will initially increase at an increasing rate. That is happening here. Then your output, this diagram is not exactly a perfect one. This is supposed to be somewhere here. Okay, let me draw it in other way. Let me draw it in other way. Little bit modification. This is happening in this way, maybe somewhere here itself. Your output is increasing at an increasing rate. Okay, then output will increase at a constant rate. Then output will increase at a decreasing rate. Here output is increasing at a decreasing rate. Okay, and when your this output is increasing and marginal product is maximum, here this one, this point is called point of inflection. Point of inflection, where marginal product is maximum. So in stage one itself, if you study the three different stages, you will get some contrasting feature in three different stages. First of all, law of diminishing marginal return says that when more and more unit of a variable input is added to a certain amount of fixed input, output will initially increase at an increasing rate. This is actually increasing maximum, becoming maximum here. This diagram is again not a very perfect one. Output is increasing at an increasing rate, then output will increase at a constant rate, then our output will increase at a decreasing rate. That is happening. So actually,
So how do you determine the point of inflection?
I am telling you. So point of inflection is that point where your marginal product is maximum. Marginal product is maximum. Actually, marginal product is becoming maximum here. This is the point of inflection. Okay, and this graph will be, you need to open it up somewhere, maybe some economics book. You will find this nicely, this kind of diagram. Just a minute. This is your average product with respect to labor. This one is marginal product. This one is your marginal product with respect to labor. This is your marginal product, this curve. If you plot these values, you will get more or less this kind of shaped curve. And here you will find your stage one. This is actually your, sorry. This is actually your stage one. This is your stage two. In that way, it happened. Okay. Now, so point of inflection, you are deciding based on when your marginal product is maximum. So if you study these three stages of production, you will find that basic question will see in stage one, both marginal product and average product is increasing initially, then marginal product becoming maximum in stage one, that is your point of inflection. Then in stage one itself, marginal product starts decreasing. This is your marginal product, pink color. It starts decreasing. But throughout that stage, average product is increasing. Stage one ends when marginal product is equal to average product, or average product is maximum. These are some imaginary stage. In front of you, that diagram is there. Because of that, you can identify in that way, you can write also. But in reality, think about your factory. You are increasing one after another unit of labor, you are increasing, suppose. Then exactly finding out exactly that this is that end of stage 1, this is that end of stage 2, it is very, very difficult. And that question I am going to ask you. Anyway, stage 1 ends when marginal product is equal to average product. And or where average product is maximum. In stage 2, both are decreasing. Marginal product starts decreasing in stage 1 itself. But in stage 2, marginal product and average product is decreasing, but rate of decrease of marginal product is much higher than average product. It is below your average product curve. Its slope is much higher. Stage 2 ends when marginal product is equal to 0 or when total product is maximum. Total product is maximum or marginal product is 0. And in stage 3, marginal product is negative or total product is rather decreasing. That is the stage 3, where marginal product is negative or total product is decreasing. That is your stage 3. Now question arises here that suppose you are a producer. Question will arise here that which stage you want to produce. Indirectly what I am asking you, see, in your production, suppose you are producing a pen or rice or whatever it is. Suppose you are producing a rice. Labor is the variable input. Which stage you are produced means how many units of labor you are going to produce. All other inputs are at certain level, fixed, except labor. You are producing rice, suppose, or you are producing, say, a pen in a factory. So how many units of labor you are going to use? Going to use in your production? So that is a question mark. Indirectly, which stage you are going to produce and why? If I give you a range, stage means a range from here to here, second stage, third stage beyond this one, first stage from beginning to here. Which stage you are going to produce? That is a question. Numerically, you can easily find it out. Numerically. But in reality, in front of you, this kind of graph will not be there, as I say. Such kind of equation will also not be there. How we are going to do it? How you are going to do it? Suppose I started producing a pen. Initially, I used one labor. Then I got some output. I calculate its marginal product, average product, so and so on. Then I use second unit, third, fourth. Each and every step, I am going for back calculation of marginal product and average product. Each and every stage, I am just doing it. Then only I will get the idea.
So what is our aim? To maximize the total product?
So under a given setup of, because we are basically discussing a short run production process where all other inputs are at certain level. So your objective is to find it out the optimal quantity of labor you are going to use in a short run under a given setup. Setup means your factory is there, machine is there, everything is there. That you cannot change. Those are at certain level, fixed, because time period is short. How many units of labor you are going to use? Or in another way, I am asking you in which stage you are going to produce, if not accurately that value right now, initially. Which stage you are going to produce? Choosing a particular stage means indirectly you are telling me a range of labor you are going to use. Then I will come to your accurate value. Because 3-stage explanation I give it, some of the basic characteristics. Roughly, if you can tell me. Do not worry for mistake. Let it be. But whatever is coming to your mind, you can share with me, maybe.
The stage 2.
Stage 2. Then why not stage 3? Simple question. I'm just trying to, because ultimately I am going to explain. Why not stage 3?
So because in stage 2, the total product is maximum, total production.
Total production in maximum in stage 2 means here. This point.
Yes, sir. At the end of stage 2. Yes, sir.
So you mean to say that it is the point where marginal product is equal to 0.
Yes, sir.
Total product is maximum. So it is the point between stage 2 and stage 3 that you are telling about. But I am
Yes, sir.
saying that why not stage 3?
So our objective should be to maximize the total product so that our profit is maximum, right?
Any other answer?
Sir, also the labor is less.
Labor is less where?
Sir, in stage 2.
Stage 2 where? Here? In on stage 3. You mean to say that one?
Sir, I mean that in stage 2 we are maximizing our production and labor is comparatively lesser than stage 3.
Okay. So now my simple question, my simple answer in this case, I will not go to any complication. Stage 3 I will not produce. Why? Because in stage 3 my marginal product is negative or total product is decreasing. I am using more and more unit of labor. Instead of increasing my total output is decreasing rather. So if this is the case, why will I go for stage 3? Because nothing is freely available. Even labor I am hiring from labor market. So it is not freely available. So if it is not freely available, why I will hire someone to reduce my production, to reduce my level of output? No way. Are you getting my point? Say, for example, I'm giving you an example. Say a situation is something like that. Suppose in my factory, optimal requirement of labor is 15, suppose. Hypothetically, I am saying that it is 15. Instead of 15, I recruited 20 labor. And these extra 5 labor, they are underutilized. Or most of these laborers are underutilized now. When they are underutilized, they might be busy in your they might be busy in non-productive activities, might be in gossiping, might be forming labor union, might be in all kind of non-productive activities. That is one possibility, maybe. So instead of getting even think about a production of suppose rice in our example. Requirement, suppose variable input in this case is fertilizer. Optimal requirement of fertilizer is 15 kg. I applied 20 kg of fertilizer, urea. Because of toxicity of nutrient, crop may die. Those might be from agriculture, they will understand it. If you apply a high dose of nitrogenous fertilizer, what will happen? Nitrogenous fertilizer is very good for vegetative growth. Some rice, probably in rice field, you probably observe if nitrogenous fertilizer is applied in high doses, so your stock growth, vegetative growth of the crop will be very high. It will be so high that root portion will not be able to support the vegetative portion, above ground portion. Crop will fall down. Ultimately, there will be crop loss. One possibility is that extreme case is toxicity of fertilizer, nutrient. Because of that, your crop will die. Your crop will die. This is one possibility. But even otherwise also, even this is called your lodging loss. So because of lodging loss also, ultimately your output is less. So not necessarily that some inputs you are increasing in excessive quantity, all other things are at certain level, you will get higher output. No, it is not like that. So stage 3 is out. Stage 1. Why not stage 1? Because you say that your objective is to maximize output. But stage 1 is not here. Because directly, stage 1 is not here because throughout that stage, marginal product is increasing, it becomes maximum, then marginal product starts decreasing. But throughout that stage, average product is increasing in stage 1. Average product is increasing means what? On an average, each and every unit of labor is contributing. On an average, each and every unit of labor is contributing more and more. Average product is increasing indirectly. I am here to teach you or discuss it in class. Average product is increasing means what is happening? Average cost of production is decreasing. Because when we calculate average cost is total cost divided by Q. This Q is increasing each and every case. Q denominator is increasing at much higher rate. Total cost is with respect to labor, average cost of labor or total cost of labor with respect to labor. Suppose labor wage is fixed. Suppose 300 rupee per unit of labor. So total cost is increasing at a constant rate. Output is increasing at an increasing rate. Much higher rate it is increasing. So ultimately this value will decrease. So average cost is decreasing. So average product is increasing means for the time being you assume. What happened? Mr. Jatin Kumar, can you hear me? Mr. Jatin Kumar, are you there?
Yes, sir.
So what is happening?
Nothing, sir.
No, nothing means your sound was coming from your system.
Yes, sir. It was by mistake, sir.
Okay. So average product is increasing means average product is increasing means average cost of production is decreasing. Because of that, stage 1, you are not stopping adding additional unit of labor. You will go on adding more unit of labor. Because of that, stage 1 is also out. But whatever you say, that answer is also wrong. Because you are not going, your decision will be to produce at the beginning of stage 2, not at the end of stage 2, because your objective is not to maximize production. Please remember, you are a producer, you will always concern about your average product, not your total product. You can produce using your resources, you can use it, but all the time you are concerned about your average product only, because it is having a link with your marginal, your average cost also, and ultimately your profit also, because in your production, ultimately you are always, you cannot think about even marginal product, rather you are concerned more about your average product. On an average, how much each and every unit of labor is contributing. So your objective is not to maximize production by excessive use of labor or input. Your objective is to rationalize your use of your inputs so that you can get a higher profit. That is your objective. Now, in this case, why at the beginning of stage 2? That is a question mark. Because technically speaking, when your average product is maximum, average cost is minimum. Because of that, actual answer is when your average product is maximum, that will be the point of your production. That will be the point of your production. So it will be minus 2L plus 15. 2L plus 15. That you will get it from these values in a tabular form. When you are calculating it out, you will find your average product. Here, you will find your average product will go on increasing, then it become maximum at some values. I do not know, I didn't calculate it out. Then it starts decreasing. Initially, this portion, average product is increasing. Each and every unit, additional unit of labor you use it, average product will go on increasing, it become maximum, then it starts decreasing. That you will find it. Anyway, now what is happening here? Why I said at the beginning of stage 2? Because what is happening in front of you, as I said at the beginning, this graph or this equation is not there. What you are doing it? You added 1 unit of labor, then you calculate it out, end of that production season or end of the day, you calculate it out. What is your total output? What is your average product? What is your marginal product? Second case, you added 1 additional unit of labor, calculate it out, then you made a comparison with your previous case. What was my average product earlier? What is my average product now? Suppose you realize that average product increase. So you will go on adding. Each and every case, you are making a comparison with previous value. In that way, you are going on increasing. In that way, how will you know that this is my maximum value? To realize your maximum value, you have to enter here. The moment you enter here and you calculate it out, average product, and you find a lower value because you are comparing with previous value. The moment you realize that, oh, my average product decrease. Average product decrease means average cost starts increasing. Immediately you stop adding additional unit of labor. And please remember, this is 1, 2, 3, 4. In that way you can write, but this may be labor may be in 100 also, unit may be 100 unit of labor, 200, 300, 400. So your actual value may come in between also, maybe 550 or something like that. Some value may come. So do not worry for this unit. Sometimes this unit may be sometimes this unit may be 4.5 maybe. I do not know. If you calculate it out, accordingly you will get those values maybe. Okay. So in this case, there is every possibility that in this case you may get your maximum value when your this value might be around 6, maybe 6 unit of labor. When it will be there, then average product will be maximum. In this case, it may be. Okay. Actually, it is 2L means I10 and 6 point something maybe. I am not very much sure, but it may be around 6 or 6 point maybe. No, it is actually 7 maybe. 7, around 7. See how I am calculating it out. Approximately, it is not actually 6, it is 7. 7 or 7 point something. Because when average product is maximum, slope of average product curve will be 0. Which means dAPL by dL will be equal to 0 when it is maximum. Slope is 0. Then equation will be, then this equation will be minus 2L plus 15. That is the equation. That is equal to 0. That is equal to 0 means L is equal to 7.5. This is the exact value. So numerically you can calculate it out easily. 7, when it is 7.5, your average product will be maximum. So in numerically fraction of second you can calculate it out. Okay, is it clear? Any question from your side? Do you have any question? Can you hear me?
Yes, sir. No question.
Okay. Now the question, the next step is, because this is not our complete story. Because what happened, whatever we discussed, this is your short run. But in long run, you mute your system. If you are having anything to ask, you can ask me. Otherwise, or any question if you have, you can ask me. Otherwise, you mute your system. Now, in your theory of production, means next step, we are discussing your theory of production. Okay. We are basically discussing theory of production. Now, production with one variable input. Now, next one is your long run. Long run means in long run, we are discussing production with two variable input. Means we assume technically it is actually production with all the variable input. Means your long run, all inputs except technology, all inputs are variable. So here production with two variable input. Inputs. And here we are considering two variable because it is two-dimensional. But in reality, in long run, we consider n number of variable and all of them may vary. Suppose you are considering a time period of, say, you are considering a time period of, say, 5 years, 10 years, 20 years, something like that. So all of you, except technology, all of your inputs are variable. So here also you will find those your assumptions. Assumptions mean there are only two inputs, labor and capital. Okay, two inputs, variable, labor and capital, to produce a certain quantity of X or to certain a commodity. Then, as I said earlier, also I said that labor can substitute capital or capital can substitute labor at a decreasing rate up to certain extent, certain limit. And production function is continuous, means labor and capital are perfectly divisible and can be substituted any small quantity. Means in same thing is applied. Means using a small quantity of labor and capital, you can produce a small quantity of labor output. You can produce a small quantity of output. These are general, and along with that, obviously, your technology is at certain level. Those issues are there. Now here, long run, another concept is coming into picture that is called your isoquant. Isoquant or isoquant curve, you can say. Iso means equal, quantus means quantity. Okay. From Greek word it came. Okay. Iso is a Greek word, it's equal, and quantus is a Latin word, this quantity means equal quantity. This is also called isoquant curve. This is also called production indifference curve. Okay. Or this is also called equal product curve. Isoquant curve or equal product curve or production indifference curve and so and so. So how we define isoquant? Okay, I can draw it here also. Suppose what is happening here, you are using labor and capital, both labor and capital may vary. So suppose you are using labor and capital, suppose x-axis labor and y-axis capital. Using labor and capital, okay, using labor and capital, you are producing certain level of output. Suppose there are n different outputs, n different points. Each and every point represents a particular combination of labor and capital. Please remember, as I say, it is symbolic because in reality, there may be n different output. So accordingly, this will be n plus one dimension. Because why 1 plus 1 dimension? This z-axis here, suppose represents level of output. Means there are n different points in a production process. Using labor and capital, you are producing some output. If z-axis represents level of output, then each and every point represents a particular level of output. Suppose this is a point A suppose. A represents certain level of output. That output you are producing by using certain quantity of labor and certain quantity of capital. Another point is there, suppose B. B represents again certain quantity of labor and certain quantity of capital. Using that one, you are getting some value of output, Q, suppose. So in that way, there may be n different points. Each and every point represents a particular level of output. That you are getting it by using capital and labor. Now, when there are n different points, there may be a few points where level of output may be same. There may be a few points where level of output Q is same. That possibility is there. Because some producer may produce capital intensive production process, and some producer down the line may be there. I'm actually joining those points. Some producer down the line may be there. Suppose it is D, here another point is suppose C, so and so. A producer is there who is using maximum unit of labor, same level of output he or she is using or producing by using more amount of labor and very less amount of capital. Because his production process is labor intensive. But there may be a possibility that he may also get the same level of output. When there are n different points, there may be a few points where level of output may be same. And if I join those points, I am getting a curve. This curve is called Ishok-1 curve or equal product curve or production indifference curve. This is called an Ishok-1 because it is joining those points, is joining. So these Ishok-1s represent suppose a level of output 100. 100 unit of output it represents. Each and every point represents a level of output that is equal to 100. Only your production process may be different. Someone might be capital intensive, someone might be using a labor intensive production process. And similar to your indifference curve, you remember? Do you remember indifference curve? But please remember, right now I am talking about Ishok-1. Right now I am talking about Ishok-1. But earlier we discussed indifference curve. We discussed 4 properties. Similar to indifference curve, here also you will find in Ishok-1s have 4 properties. Negatively slope, convex to the origin, 2 Ishok-1 never intersect. Higher the Ishok-1, higher will be the level of output. Means there may be n number of Ishok-1s parallel to each other. This Ishok-1 is having suppose quantity represents a level of output equal to 200. So and so. So it is negatively sloped, convex to the origin, 2 Ishok-1 never intersect. Higher the Ishok-1, higher will be the level of output. Here you see, this is the higher Ishok-1. Because here might be more quantity of labor and capital you are using it. But then obviously you are getting more level of output. That possibility is more. And how we define an Ishok-1? How you define an Ishok-1? Not a classical definition, but obviously just like indifference curve you can define. It is the locus of points representing different combination of 2 inputs, in this case labor and capital, yielding a same level of output. It is the locus of points representing different combination of 2 inputs, capital and labor, that produces same level of output. Throughout that Ishok-1, level of output is 100. This Ishok-1 is having a output level of 200. So and so. So negatively slope convex to the origin. Then two isoc 1 never intersect. Higher the isoc 1, higher will be the level of output. And here in an isoc 1, you will get some other, just like your indifference curve, here also you will get marginal rate of technical substitution. It is the rate at which one input is substituted by the other. It is the rate at which one input is substituted by the other. Means in other way, you can write this is your del K minus by del L, because when you move from A to B, B to C, C to D, you are substituting capital by labor. So del K means you are substituting. My negative sign is for substitution. Del K by del L. This is the rate at which one input is substituted by the other. Indirectly, this is the slope. Indirectly, this is the slope of isoquant. This represents MRTS. Slope of isoquant. Indirectly, MRTS represents slope of isoquant. Okay.
Sir, is it necessary if capital is less than labor is more or something?
It is capital is less and labor is more. I'm not getting. Is it necessary means what do you mean by this one?
Because if in graph it is being shown that if capital is less for us, then there is a more labor requirement, and if capital is more,
that is required because you are considering only labor and capital. Okay, you are considering labor and capital. Now you are substituting capital by labor. This is the case, because otherwise what will happen? Suppose you are decreasing capital, keeping labor at constant level, only capital is decreasing. Your output will, you will get a different level of output. You will not be in same isoc one. Are you getting my point?
yes, sir.
So that will be the case. Means you will get altogether a different value. Means, say for example, I have to draw it in this way. Maybe suppose here. Think about this one. Suppose this is a point of E in higher isoc 1. Okay. What you did in this case, you keep your if you reduce both capital and labor, you will come down to your lower isoc 1. Output level will be less. But otherwise, keeping your capital constant, but you reduce labor, suppose you move to B, suppose at B, same unit of capital you are using, suppose it is 5 unit. At E also you are using 5 unit, at B also you are using 5 units. So capital level is same. But here labor is, suppose here it was 10, here it is 5. Earlier your labor was 10, now you reduce labor with 5. So 5 unit of machine, 5 unit of labor you are using it here. So as there is a decrease of labor, you move to your lower isoc 1. In this case, if you substitute it, in this case, you straightway reduce, keeping other input at certain level, straightway you reduce that use of other input. Because of that, your output level come down. But not doing that one, if you substitute it, suppose labor you reduce it, you move from E to this one, or from D to B, from D to B. Suppose you move it from D to B. In reverse way also you can move. D to B you move it from same isoc 1. What you are doing it? Labor was 10, now you reduce it to 5. That is fine. But earlier suppose machine was only 3, When you move from D to B, what you did? Number of machine you increase from 3 to 5. Number of machine you increase from 3 to 5. Labor decrease here, labor decrease from 10 to, sorry. Labor decrease from 10 to 5, but number of machine increase from, or capital increase from 3 unit to 5 unit. Because of that, it was somehow balanced. Because of that, you are in same ISO one, same level of output. It may happen. But in this case, what happens straight away, keeping that one input constant, other one you reduce it. So ultimately, there will be decrease in output. Okay. Now, I'm giving you another dimension here about marginal rate of technical substitution. Think about this graph, suppose. Think about this graph. Suppose when you move from A to B, you substituted del L, del K quantity of capital. Suppose this was 7. So it's, you reduce A to B, you move it. So 7 to 5 means del K is 2 unit. And here it represents del L, suppose. But when you move from A to B, suppose this is your 3 unit to 5 unit of labor, you increase your labor, del L. So change in labor is del L, change in capital is del K. Now what is happening? You substituted del K quantity of capital. Negative sign represents your substitution, decrease in value. Okay. If you multiply del K is the change in capital. Multiply it with marginal productivity of capital. Then that will give you marginal productivity of capital. That will give you your total output loss because of your sacrifice of your capital. Means what I mean to say, when number of capital or unit of capital use decrease from 7 to 5, 2 unit of capital decrease, multiply it with marginal productivity of capital, per unit productivity of capital, you are multiplying it, then that will represent your total output loss because of your sacrifice of 2 unit of capital. So this represents your total output loss because of your sacrifice of capital. In this case, in our example, 2 unit. Suppose. But when you move from A to B, some additional quantity of labor you started using it. Not necessarily always it has to be 2. Not necessarily, it may be any value. Because unit of capital and labor may be different. In different way you can express. So del L amount represents your additional use of labor. When you use additional unit of labor, that labor will contribute to your production. And if you multiply del L multiplied by marginal productivity of labor, that will represent your total output gain because of additional use of labor. Because of additional use of labor, you will get some extra output. This portion will represent your gain of total or additional output of labor with respect to labor. Additional output. This represents your loss, this represents your gain. But as per the definition of ISO quant, what is happening? Along that ISO quant, your level of output remains same, equal quantity. Because of that, your gain and loss must be equal. Then only you will be in same ISO quant. Otherwise, you will move on to other ISO quant. In other way, if you simplify it, you will get minus del K by del L equal to marginal productivity of labor by marginal productivity of capital. This represents what? This represents your MRTS, marginal rate of technical substitution. here I wrote it just now, is also equal to your marginal productivity of capital by labor by marginal productivity of capital. In that way, you can go on discussing. Clear? Any question?
Sir, what is minus delta K dot MPK?
This is your total output loss. Delta K is your change in capital or loss in capital multiplied by marginal productivity of capital. Okay, with respect to capital, marginal productivity. You remember marginal productivity with respect to labor? We just calculate it out. It's similar way you can do it. Are you getting my point? Here it is with respect to labor. It may be with respect to capital also. dq by dk. Because capital is changing here in long run. And here it is marginal productivity of labor. If you multiply it, you will get the total output gain, and this represents total output loss. But this is must be equal, then only you will be in same ISO 1. Otherwise, you will move on to other ISO 1. So ultimately, you are getting this kind of equation. Okay. MRTS is equal to ultimately marginal productivity ratio, you can say, of labor by capital. Now, the question is, in an ISO1 map, you already know by this property. In an ISO1 map, there are number of ISO1s. Each and every ISO1 will represent a certain level of output. They are parallel to each other because they are not intersecting. Higher the ISO1, higher will be the level of output. But each and every ISO1. So what is that property says? These are negatively sloped and convex to the origin. Negatively sloped, convex to the origin. But technically speaking, if it is negatively sloped and convex to the origin, then there is a possibility. Right now, I am not having that one in Dominic Salvatore's that book. Right now I am not having that example. But anyway, next class I will show you definitely. Maybe next class I will show. This is not. Do not worry. I will just bring certain values from that book, maybe. Or I may have a copy, scan copy. I have to search it maybe. Anyway. So it is negatively sloped convex to the origin. Means what happened? Each and every ISO1 you will get two extreme points. That separate actually negatively sloped portion from positively sloped portion. Means an ISO1 may be even a positively sloped also. Suppose this is an ISO1. Positively sloped portion. So each and every ISO1 there will be two extreme points. Each and every ISO1 there will be two extreme points. That separates negatively sloped portion from positively sloped portion. This side also you will get positively sloped portion. Now this is a possibility. Say for example, say I am telling you, suppose this is a point in your ISO1. This is a point in your ISO1, suppose, where use of labor is, suppose, hypothetically, 10 units of labor. This side is your labor. This side is your capital. Use of labor is 10 units, and this is your so 5 units. 5 units of capital and 10 units of labor. Same level of output. This represents, suppose, 100 units. This represents 100 units. This represents 200. Simple logic, because your inputs are not freely available. Same level of output you can produce by using 5 unit of capital and might be 3 unit of labor. Then where is the point of producing at this particular point? And by the way, this is extreme case. This is in other way also you can represent it in other way, maybe. Means what other way I mean to say here, suppose you remove this one, not required even. In a simple way, you just draw it, maybe here, somewhere here, suppose. Same amount of output you can produce by using 5 unit of capital and 3 unit of labor. Then where is the point of using 10 unit of labor? No producer will go and produce at 10 unit of labor because this is simply wastage of your inputs. Simply wastage of your money. Because of that, always we consider this negatively sloped portion of an ISOC 1. Because in negatively sloped portion, your point of production may vary. Someone might be producing at point A, someone might be producing at point B. That is technically all right. Because at B, what is happening? You might be using, might be 6 unit of labor, or maybe 4 unit of labor, suppose. 4 unit of labor and maybe 4 unit of capital at B. Because in comparison to A, B is more labor intensive production process is using because less number of machine and more number of labor they are using here at B. So from producer to producer, it may vary. You may produce A, you may produce at B, someone may produce even at C also. At C, harder might be you are using 6 unit of labor, but your number of machine may decrease to, suppose number of machine may decrease to suppose 3 unit. So ABC, it is okay. Depending upon your convenience, you will do it. Okay, because here level of this level of output is same, but your inputs are at different level. Okay. One is capital intensive, another is labor intensive. But producing at this particular point, suppose this is point E, it is purely meaningless. It is wastage of your inputs. Same amount of output you can produce by using only 3 unit of labor and 5 unit of capital. So where is the point of using 5 unit of capital and 10 unit of labor? Because nothing is freely available. This additional 7 labor is simply unused in your production process. So no producer will go and produce in this way. Because of that, negatively sloped portion of ISOC 1 is said to be technically efficient. And any producer try to produce here in negatively sloped portion of ISOC 1. Because here your production will be technically efficient. There will not be any wastage of your resources. Combination of labor and capital may vary, like labor intensive, more labor intensive or more capital intensive. It may vary, but it will be technically efficient, your production process. Okay. Here comes actually your 2 lines, ridge lines are coming into picture. Upper ridge lines represents those in this way. Each and every ISOC 1, what will happen? You are joining only those points where, because each and every ISOC 1, you are getting certain points which will separate positively sloped portion from negatively sloped portion. In that way. So joining those points, you are getting your upper ridge line and lower ridge line. Just remind me in next class, upper ridge line, I'm just writing it, ridge line, and this one is called your lower ridge line. This is called upper ridgeline, lower one is called lower ridgeline, and this is called your economic region of production. This area, I will discuss it next class. Okay. In the context of economic region of production. The area between upper ridgeline and lower ridgeline is called your economic region of production, where your production decision will be technically efficient. Okay. This is that one. So next class, I'm stopping it here. If you have any question, you can ask me. Can you hear me?
Yes, sir.
Okay. In between, it shows some bad network. But in case you have any question, you can ask me. And this ridgeline and other things, do not worry too much.